Alright, I want to do a little lesson on asymptotes. So we'll start with, there are three different types of asymptotes. There's vertical, horizontal, and oblique or slant. So we'll start with vertical. It's probably the most common type of asymptote, and it's just vertical lines. In this particular picture, the red lines pictured are vertical asymptotes. So x equals -2 would be an asymptote, and x equals 2 would be an asymptote in this particular picture. And the way that you figure out your vertical asymptotes is you, first of all, make sure everything's simplified. So I have 2x minus 3 on the top, and the bottom would factor to x plus 2 and x minus 2. And you want to look to see if you have any common factors, which I don't. And as long as I have no common factors, then the zeros of the denominator are my vertical asymptotes. So x plus 2, set that equal to 0. X minus 2, set that equal to 0. So I would get -2 and +2 are my vertical asymptotes. And notice I said if there are no common factors. Sometimes there are common factors, and so those can cause, you want to eliminate those first. Let's say, for instance, see it says with no common factors. Let's say I had something like x plus 3 times x plus 7 on the top, and on the bottom I had x plus 3 times x minus 4. Well, since the x plus 3 is on the top and the bottom, that would not be considered an asymptote. The only one I would worry about is the x minus 4. So my only vertical asymptote here is 4. -3 would not be a part of the domain, but it would not be considered an asymptote. So because that would be a common factor. Horizontal asymptotes are ones that are horizontal lines. So this blue line here, y equals 2, would be a horizontal asymptote. And here's how you find the horizontal asymptotes. When the degree of, that's terrible, that didn't transfer over right. It was on my PowerPoint and that didn't transfer over good. When the numerator and the denominator of a rational function have the same degree, the line y equals a over b is the horizontal asymptote. So for instance, let me give you an example for this. If I were to have y equals, or f of x equals, probably would be better, f of x equals for my function, if I had 2x squared plus 5x plus 3 on the top, and I had, let's see, x squared plus 8x minus 7 on the bottom. The degree of the top is 2, the degree of the bottom is 2. So the line y equals, I'll look at my coefficients, 2 over 1, or y equals 2, would be my horizontal asymptote. If I were to have f of x equals 18x cubed plus 7x squared plus 5x plus 3, it could keep on going. And on the bottom I had 9x cubed plus 5x squared plus 8x plus 3. What I'm only looking at is they both have a degree of 3. So the line y equals 18 over 9, or y equals 2, would be my horizontal asymptote. It's not always y equals 2. I know that was probably a bad choice for me because I picked things that were both 2. Let me pick one that's not right quick so you know it doesn't have to always be 2. If you look at the examples that we did the other day, you'll see some that were not 2. But let's say I were to have, excuse me, f of x equals, how about 5x minus 7 on the top and 2x minus 3 on the bottom. It would be y equals, these have the same degree, so it would just be y equals 5 halves. That would be my horizontal asymptote. And that's when the numerator and the denominator have the same degree. When the degree of the numerator is less than the degree of the denominator, the x-axis, or y equals 0, is going to be the horizontal asymptote. So if I have y equals x squared here and x cubed here, then y equals 0 is going to be your horizontal asymptote. And it could be 2x squared and 5x cubed, doesn't matter. If this degree is smaller than this degree, then y equals 0 is your horizontal asymptote. And the last rule is the degree of the numerator is greater than the degree of the denominator, there is none. So if I had a x cubed on the top and an x squared on the bottom, there would be no horizontal asymptote because this degree is larger than that degree. Alright, lastly, and this is what we didn't get to in class the other day, and that's oblique asymptotes, or sometimes they're called slant asymptotes. This blue line is an oblique asymptote. Well, how do we know we have oblique asymptotes? And I'm going to redo that. X squared minus, I think the top was x squared minus 2. I'm going to look at what it was on my thing. When the degree of the numerator is 1 greater than the degree of the denominator, you divide to find an equivalent expression, and that's going to give you your oblique asymptotes. So, I think this was x squared minus 2x on the top, and then maybe x minus 3 on the bottom. Let's try that. I'm just going to make this one up. X squared minus 2x plus 5 on the top, and x minus 3 on the bottom. This would have an oblique asymptote because this degree is 1 greater than this degree. So when that happens, the easiest way to find your oblique asymptote is to do synthetic division. So I'm dividing by x minus 3, so I'm going to put a 3 on the outside, and then my coefficients are 1, negative 2, and 5. Bring down the 1. This is why we did synthetic division in an earlier section to help us also here. 3 times 1 is 3, and I add, I get 1. 3 times 1 is 3, and I add, and I get 8. And it doesn't matter what the remainder is, you're not going to use that. What you're going to use is this part right here. The line y equals 1x plus 1 is your oblique asymptote. So if you had to graph that, you'd start at 1, that's your y-intercept, and your slope, that's 1x, so your slope is 1, so you go up 1 and over 1, and you draw, can't draw very good, but you draw this line, and that's my oblique asymptote. If I were to have something like, I'll just make up another one, on the top if I had x squared minus 8x plus 4, and on the bottom I have x minus 5, I'd put a 5 on the outside, and I'd have 1, negative 8, and 4. Bring down the 1, 5 times 1 is 5, add, you get negative 3, 5 times negative 3 is negative 15, add, you get negative 11, doesn't matter what your remainder is, this is what you're going to use. The line y equals x minus 3 would be your oblique asymptote. So that's how that works, and that's vertical, horizontal, and oblique. So hopefully you can read through these notes that I'm putting up here. Vertical asymptotes occur at any x values and make the denominator 0 as long as they have no common factors. The x-axis is your horizontal asymptote, and the degree of the numerator is less than the degree of the denominator. You can pause all of this. I'm going to leave it here for a second, and then we'll go to the next screen. You can pause it and read those on your own. But that is a little bit about asymptotes, so section 4, 5, and graphs of rational functions.